live. I'm coming in, trying to get my face in here. And okay, welcome. Good morning, everyone. Let's get that overhead screen on. We are here, and it is Tuesday, if all is going well. We are coming to you live from Santa Barbara, California, Westmont College, Winter Hall. It's Mayterm 2018. This is CS-030. Today we are learning about Java. This seminar is part of a 5-week class. Today's lecture is scheduled for 2 hours. And for those of us that are in the room and that are participating remotely, we are communicating in real time by Slack channel on #broadcast questions. I'm monitoring it down here by my side. So shout out to our remote participants and all the people watching us on YouTube later, I suppose. Hope you all learned something by virtue of what we're doing here today. So for those of us that are here and live, let's just take a second to make sure we're arriving, recognize that we're here, turn off our notifications, and shut down anything that is otherwise distracting for us. For me, that's notifications, and I guess that's about it. Other things are supposed to be distracting, like Slack. Last week, we talked a little bit about some issues around legality and maybe holiness, and talking about the ways in which different things are. There are some things that we might encounter as part of technology that are technically legal, but maybe not up to the highest standards that we would want to hold ourselves to, or that God would hold us to. You know, and a very simple example of that is we get access to someone's account, we get access to some information, and we didn't break any laws in order to get that, and then we have to decide whether or not we want to do something with it. So that's a case where the law doesn't fully protect something, or isn't an indication of how, what standard we should be holding ourselves to. But today I kind of want to flip that around a little bit, and I want to think a little bit about laws that are too restrictive and ways in which we may actually be prevented from doing things that we should be doing because of laws. So a motivation for that then would be coming from a text in Mark, story about Jesus walking along. And the text reads, "One Sabbath, Jesus was going through the grain fields, and as his disciples walked along, they began to pick some heads of grain. And the Pharisees said to him, 'Look, why are they doing what is unlawful on the Sabbath?' And he answered, 'Have you never read what David did when he and his companions were hungry and in need? In the days of Abiathar, the high priest, he entered the house of God and ate the consecrated bread, which is lawful only for priests to eat. And he also gave some to his companions. Then he said to him, the Sabbath was made for man, not man for the Sabbath. So the Son of Man is Lord even of the Sabbath.'" So there's a lot we could read there about the Sabbath and about taking rest and what the point of the Sabbath is. But I want to just sort of draw the attention to the fact that in this case, Jesus is confronted with a law which he deems to be not effective, not correct, because it is legislating or regulating something that shouldn't be regulated. So in a broad case, we might run into this in different circumstances. Historically, in the U.S., we had a real clear example of that with slavery, because there was a point in time in the U.S. when slavery was legal, and honestly, there were quite a few Christians during that time that really struggled with the idea that American slavery might be wrong, because they said, well, it's legal. How could something that's legal be wrong? And so this is an example of a case where a law is allowing something which maybe isn't correct, sort of the flip side of what we saw beforehand. And so we have to think very carefully about situations where the law is allowing something which shouldn't be allowed, and whether or not, on the one hand, whether we want to do something that maybe is legal, but also whether or not we want to live in an environment, a society, in a culture where something is legal. How does this play out technically? Well, technologically, things don't seem to be quite as grand a scale as slavery, maybe. But there are some circumstances where there are certain things that have become illegal that maybe shouldn't be. Let me draw your attention to one. There's something called the Digital Millennium Copyright Act. And I don't know if you're familiar with this or not, but it is a law that criminalizes circumventing access controls, regardless of whether or not you own something or whether or not you actually commit some copyright infringement. So basically, this is a law that says you are not allowed to, if someone puts some sort of technological barrier against you to do something with some sort of technology, and you circumvent that protection technology, you are now in violation of this law, the Digital Millennium Copyright Act. So what might this be like? So this might be like a circumstance where you own software and you would like to make a backup copy. In order to make a backup copy, you have to maybe break some encryption in order to get a copy that works, because it's not allowed to, you're not technically able to do that copyright. So the question is, shouldn't you be able to back up your own software that you've purchased? Not a situation where you're going to sell it, but a situation where you're keeping it as sort of a resilience mechanism to make sure that you don't lose access to the thing that you purchased. Or here's another hypothetical example. What if you bought a digital book and you could only view it on one particular digital reader, and it's encrypted so that it only works with that reader, and that company goes out of business? Should you be able to hack into that file that you have to be able to access the book that you purchased and which you can no longer access because the company went out of business? In this case, the Digital Millennium Copyright Act says no, you can't. If you're circumventing a something that has been protected, even if you own it, even if it's not about copyright infringement, you can't do that. So I would argue that this is probably an example of a law which in some cases is okay, right? You shouldn't be breaking copyright to go sell some movie or sell some book which you didn't write, you didn't own, you don't have the copyright over. That seems like that's fair. But there are a lot of cases where the actual act of circumventing security mechanisms, I just don't think should be criminal. Nonetheless, I would tread very carefully, because in any circumstances where there is something that is made illegal and you're saying, no, that should be legal, you are definitely coming up against breaking a law, right? And you shouldn't do that lightly. And you probably shouldn't, you should be very careful about undertaking something like that, because you very much are breaking the law. But slavery, the fact that slavery was legal and keeping slaves wasn't illegal wasn't a good law either. So the ways in which legislation and what technology does maybe isn't always lining up with what I would consider the right or the moral thing, the Christ-like thing. And part of that's because technology moves so fast, and it's hard to get political action around something that's moving so quickly. So this is very difficult. It's very difficult to be in this field sometimes when you encounter certain sorts of problems or challenges that you want to undertake, and you need to navigate some of this stuff. Like what if, for example, you find out about some security flaw in the process of monkeying around with some kind of software. You find out that, it actually is really, really easy to break into people's iPhone 11s, which as of now aren't out yet. Then what do you do? Because if you reveal the fact that you found out how to break into an iPhone 11, well, on the one hand, you're helping people out, but on the other hand, you've clearly violated this DMCA Act. So anyway, I would tread carefully, but that's a reason why maybe this is not a great law in place. Okay, so in terms of administration for the class, where are we right now? We've got a quiz on Chapter 3 due on Friday. We've got a programming assignment for Chapter 3 due on Friday as well. Got a new quiz on Chapter 5 coming up Monday. We're going to start talking about Chapter 5 today, which is about decisions. It's pretty straightforward given our background in Python. It's basically if statements. And we'll be looking for another programming assignment to come up that'll be due later next week. I need to figure out exactly how I want to organize that with the flow of what we're learning right now.
You know what chapter it's on?
What chapter the programming assignment will be on?
Yeah.
Well, hopefully it's going to cover multiple ones. It's not going to be squarely aligned with one particular chapter, because I want to get you guys, what I hope to achieve from the programming assignments is to give you guys a little bit of creativity, a little bit of ability to put multiple concepts together. That's the whole point of doing the programming, so it's not like a quiz. I just need to figure out what's the right thing to do with the organization of the classes we're doing at this term. Okay, great. So last time, what did we look at? We looked at stubbing out classes. We talked a lot about design, the design of classes. We looked at stubbing them out, which means creating the public interface for a class. And we saw how JavaDoc is an automated text processing tool that will read through a public interface if it's been structured the right way and create a nice web page for it. And JavaDoc itself is the public interface. So what consumers of our class, application programmers who want to use our class, the methods that they're going to call and what data they're going to have access to. And we also showed how test-driven development is a way to do programming that doesn't even require you to implement your class before you start writing your tests. And the thing that's good about it is that you really have to nail down exactly what your design is about your class before you start to write the code for it. And so you don't end up in a situation where you're not, you get halfway through your work and you're not sure what in the world you're even doing. So to test that out, we implemented an add interest method to our bank account class. And then as a sidebar, we walked through debugging in Eclipse because it's a really important way of actually, once you start implementing, figuring out why your tests aren't passing. Then we ended by talking about scoping of variables, and we also checked out the this keyword along the way. Any follow-up questions from that stuff last time? All right. So today I want to start by digging in a little deeper to the JUnit testing framework, and I want to make sure that we get sort of a robust filling of that out. And then Tim, you mentioned a little bit of interest in doing user interface so that you could make some kind of applications around that. So we're going to divert a little bit from the chapter content to do an example with JavaFX, which is a UI framework for desktop applications in Java. And then we're going to jump into the content of chapter 5, which is about decision making. So testing. We've seen testing. What is it? It is the process of validating that the code that you've written is working according to the specifications. So according to your requirements or according to the comments that you've written. Testing is something that's done by a developer and at the developer level, at least the kind of testing we're talking about. There's another kind of testing that you do before you deliver some sort of product to a customer. That's called acceptance testing. That's not what we're talking about. We're talking about code testing. And in particular, what we're talking about today is unit testing. And this means that we're going to be testing the functionality of individual bits of code within our project. So usually it means we're testing a class or we're testing a method. And unit testing is very, very critical to professional software development to make sure that you've got quality software. Without a test, you just really have no idea whether what you wrote is achieving anything close to what you intended for it to do along the way. So we do that to make sure that our code meets specifications. We also do it to check corner cases to make sure that we're covering all the weird situations that might arise. How are we dealing with negative numbers? How are we dealing with null input values and parameters? What do we do if something unexpected didn't happen? And the reason why is because at the end of the day, fixing your code before you put it out into the wild is so much more time effective than trying to throw out code that's broken and then recall it or send out updates or patches or deal with the PR and the customer service complaints that might come in as people find that the code isn't doing what they thought it was supposed to do, and now you not only do you have to fix the code, but you have to deal with all these customers who are having a hard time dealing with their product. Yeah, Tim.
I agree that sounds like a big hassle, but it seems like some companies still put out software that doesn't work properly and then decide to patch it afterwards and have been just consistently have a track record of putting out software that's broken on release, and I'm specifically talking about games by the company EA.
Just to throw one particular specific out there.
Yeah, but they are kind of known for putting out buggy, untested games and then patching them afterwards, like a week or two after they come out. Why is that cost? Well, why do they do it if it's not cost effective?
So let's see, there are a couple of things going on there. One is that there are different kinds of software that you might write. So for example, if you look at Gmail, Gmail is software that's written primarily, well, a big chunk of Gmail is written in JavaScript. It runs in your browser. Then there's another chunk that's server side. And with Gmail, every time you load up your browser, you potentially could be getting a fresh copy of new JavaScript code downloaded to your browser and run. So the process of writing Gmail is something where you're continually updating the code and continually deploying it all the time. And so, for example, Google has really, really strong process controls to ensure that the software that they deliver is high quality. So it involves things like when you write, first of all, they decide what it is we're doing with the code. They have a design round. They break that up into a bunch of tasks, and that's processed through a ticketing system. And a developer will take a particular task, will implement the code associated with the task, and then they will submit it to a peer, and the peer has to review that code to make sure that both the peer and the individual agree that the software does what it's supposed to do. And then if the peers both agree, then they pass it up to a senior engineer, and a senior engineer reviews it. And if the senior engineer and the peer agree that it works, they put it into the live code base that will then be downloaded by people in their browser when it shows up. And even then, they only deliver that code to a small percentage of the users at a time. So they split everyone up into groups. So you might get the new code first, and then they watch to make sure nothing breaks. And then slowly over the course of, I don't know what the time frame is, but I'd imagine something like 48 hours, everyone who accesses a particular product like Gmail will get the new code. And so they don't give it to everyone in case it breaks something. It's called a smoke test. They look to see if something starts burning out there. And if they do, they roll it back right away. So there's really strict processes in place for a software that's continuously being deployed like that, and how you keep quality. Games are not like that, right? Games usually have a release date, like a movie. And so there's this frenzy of activity within game companies within the lead-up time to when it's released, trying to get the last features in, trying to get all the graphics in place. And the other thing is games tend to be very technically advanced. So games are some of the most technically sophisticated software that's out there. And they can, nowadays they're elaborate worlds and really sophisticated networking, and sometimes they're massively multiplayer online games. So I think that what you're encountering is, one, the fact that it's released like a movie, and so you don't have this ability to sort of iteratively add features and make it get better and better. And the other thing is that it's just phenomenally complex. And each game is kind of a unique thing. It's not like you write Gmail and then you write something that's kind of like Gmail. You release, I don't know, what game are we into right now? Like Fortnite? Yeah, we're into Fortnite. And then you release some racing game, and then you release, some football game, and then you release some space game. They each can be very radically different. So I think that in one sense, it reflects ambitions of the game company to really achieve something great, and then it also reflects just the structure of the way that software gets released. And also, there's a little bit of an understanding that if something is broken, we can fix it, right? So there's a little bit of it's okay if everything isn't, T's crossed and I's dotted, because everyone's network connected now, and now we can download a new copy on Steam or however they do patches. So I think that's what you're encountering. Of course, time is money, right? So if you can fix it earlier and take less time, then it's also going to cost you less if you're doing this in a business environment or an environment where the money matters. Testing has saved my bacon so many times, it's unbelievable. From releasing bad code and from catching bugs in code that I just think was really, really simple. How could I possibly make a mistake in this super simple code? And then it turns out that I did, and the test caught it. It saved me a bunch of headaches later when, a week down the line, I'm expecting this code to be working and it's not, and I have to spend a lot of time trying to track down where the error is. So I'm really into testing. I really think it has a great value. So we in particular are using something called a JUnit testing, and this is something, it's a class of testing frameworks called regression testing. And regression testing framework is present so that you don't, as you make improvements to your software, you don't break previous software releases. So like if you're working on version 1 of your software, you write a bunch of tests that make sure that version 1 works, and you add a feature to something. Maybe you allow someone to change the font color, or enable them to add another recipient in an email message. When you do that, you keep all your old tests around, and as you add your new feature, you write tests for just the new feature, and you add it to all the tests that you had before to make sure you don't regress. Make sure you don't break something that was working as you try and improve your code. By putting it in a framework, you standardize the testing. You enable tools like the green check marks on the left to help us out and automate some of that. And we can do that fast and consistently as a result. And in fact, when you get large code bases set up, there are separate servers that will run those tests for you after you check in your code to a source code management system like Git or something. And so it's, at a big company, it's pretty common for there to just be a whole server farm of computers constantly running tests as new code is updated into a code base. And if anything ever breaks, the developer who submitted that code immediately gets notified that they broke the build. JUnit is built into Eclipse. It's part of continuous deployment environments. So there's some environments called Jenkins, and there's another one called Travis CI, which I think stands for continuous improvement, maybe. These are both automated testing systems that work with something like web-based software, so that when you submit code, before it actually goes live, it has to pass this final gateway of checks. And Jenkins and Travis CI are two tools that companies like Google or companies like Facebook use to ensure software quality. They manage those peer reviews, and it manages the smoke tests and things like that. JUnit tests can also be run from the command line. It's a little bit more complicated than just running the a Java program from the command line, but not super more complicated. I don't know what that means. Not a whole lot more complicated. And that's helpful because if you want to script your tests, if you want to write a lightweight testing environment, you can just run your tests from the command line. You don't have to fire up the whole Eclipse framework to do that. All right, so JUnit is specifically for Java, and if you're interested in seeing all the nitty-gritty for it, there's a website devoted to it. It's open source. If you're not familiar with what open source means, it means free software. And unfortunately, in English, free has two conflated meanings. On the one hand, it means costs nothing. On the other hand, it derives from freedom. And in the case of open source software, while both of those freedoms are true, the one that's more important to the open source software community is the freedom aspect of it. And what makes something open source and free software is the fact that you have access to the source code. You can read it, you can check to see what it's doing, you can copy it, you can add your own modifications to it, and typically with some kind of open source software that's covered by a license like the GPL or other free and open source software licenses, you can modify it, you can put it on your website, but anything that you modify, you also have to make available under that same license. So technically you can sell it. You can download it and sell it if you want, but it's silly because anyone can download it. And so there's a whole different business model around open source software that's not based on selling software, but it's based on selling services. So you're really good at JUnit testing. Here's a JUnit testing software. Go crazy. Good luck on figuring it out because I'm an expert on how to do JUnit testing, and you can hire me to do it. The software is free, and everyone's working together to create better open source software by contributing fixes and making JUnit better. But if you actually want to use it, then you need to hire me because I know how to use it. Same thing with like database software. MySQL is an open source database. It's very powerful. Anyone can download it for free, but you need someone that knows how to run it. And so the whole idea of open source software in terms of the business model is selling services, not selling the software. And this is really different than companies like Microsoft, which make their money on selling software primarily. And because of that open source software, it has traditionally been a real threat for Microsoft's business model, although they've been really modifying that recently. So anyway, you can go and download this or look at it, but of course it's built into Eclipse, and we've seen that. And what we use it for is to write unit test case. So this is test code that validates that our production code, meaning the code that we want to go out to the world, like a method, works as we expect it to. And to do this quickly and efficiently, it helps to have a framework. There are other frameworks, but JUnit's a popular one. Other languages have their own framework. So Node.js has their own framework called NUnit, not surprisingly. And then the key thing about the test case is we'd have to know that given a particular input, what the expected output is. And so then we just specifically try that. We say, give it an input we know, test that the output is what we expect, and if it's that way, then it passes. So we should know what the preconditions are, we should know what the postconditions are, and we evaluate it. One thing that we didn't look at very closely was how we actually add the JUnit framework to our library. And so this is what happens if you right-click on your project and go to Properties. You'll see this window in Eclipse. And if you select over on the left side the Java build path, you'll see the pane that's visible here with source, projects, libraries, order, and export. In this particular project, the JUnit 4 library is already present. JUnit 5 is the most current library. There's not a huge difference between them, but you should get used to JUnit 5 at this point. If JUnit 4 wasn't there, you wouldn't be able to run tests. It's easy enough to add, though. You just go over to where it says Add Library, and when you click on that, it'll give you the opportunity to add a framework, and after you go through that process, you should see JUnit show up. And once you have JUnit showing up there, then you're actually going to have access to a bunch of other menu selection items in your project along the way. So add in library. A test case itself is just another class. It's only existing in order to validate a separate class. So in this screenshot down at the bottom, you can see we're using our example of the clicker or the counter class, and we created a counter test class right next to it. There are different sort of opinions about where in your project the proper place is to put the test class. For our purposes, a convenient way to do it is to put it right next to the other class to take the same class name and to end it with the word test, and that way alphabetically it'll show up right next to the class, and so that as you make modifications, it's easy to just modify a test and modify the class as well. And typically there's a one-to-one mapping between unit test cases and the classes themselves. So you have the class, you have the test. You have the class, you have the tests. And sometimes you'll have additional tests that do system-level testing that test many classes all at once, but that's for another day. All right, so if we had a particular thing that we wanted to test, we would do that. We would indicate that something is a JUnit test with an annotation. And so that's this little @T test that we put before the method. And when we put this here, what we're communicating to the JUnit testing framework is that it should include this as one of the tests that it runs to make sure that all the software is running okay. So then we called the method test click. We could have called it anything. It doesn't have to have the word test in the method name. It just has to have that annotation. And then you can see in this case we have an input. The input is a sequence of actions. We create that counter, we click on that counter, and what we're saying is we expect that the value of that test counter is going to be 1 after we've done those previous 2 actions. And so the test itself is that assert true line. So this is one method, but there's only one test that's here. And that test is necessarily going to be testing the constructor and the click method and the get value in one particular configuration. Good. There are a lot of different tests that you can run. So the actual test itself are those assert methods. Here's just 6 of them that are available to you. There are many more. I was looking at the JUnit 5 list this morning, and there's maybe something on the order of 200 different tests. And one of the ways in which those tests get multiplied is because you can have different method signatures. So for example, in assert equals, you can see here that assert equals expects you to pass a Boolean value on the expected parameter and a Boolean value on the actual parameter. But in fact, there are many assert equals methods that take different types as their expected and actual. In each of those cases, it's the same for a particular method, but you have ones for Boolean and doubles and objects of all kinds. You can assert that something is false. So you want to make sure that something is false at some point. You can assert that an object is not null at some point. You can assert that an object is null. You can assert that some condition is true, and then that last one there is fail. And if the control flow gets to that particular method, the test is going to fail. And so that's a good one for checking to make sure that code doesn't throw an exception, for example. And what you can do is you can put the fail method in the catch block of an exception. And if it throws the exception, well, then you fail the test. There are some other interesting ones that are available is you can check to make sure something doesn't take too long to complete. There's a timeout method. What other interesting ones did I see this morning? There's a couple asserts that check to make sure that an exception is thrown. So you can just say assert exception thrown, and then do the method call and make sure that an exception is thrown. So there's a lot of functionality there. So just to bring it home in an example, this is a complete test class, the counter test class. You can see that we're importing some of the assertion methods up in the first line, and then we're importing the class that we're testing in the second line, and then the test class itself is called counter test, and we have 4 different tests shown here. Each of them are doing different things, and what we're trying to do is we're just trying to make sure that all of our code gets exercised to make sure that we didn't make any errors in it. Take one, for example, the one that should be above my head right there. Test reset, and that is making a counter, clicking it 1, 2, 3, 4, 5 times, and then resetting it, and checking to make sure that after resetting it and clicking it 5 times, then resetting it, that the value is 0. So these tests all describe a behavior. So one of the things that I've had the opportunity to do is I've done some expert witnessing for Apple. Let's see, what can I say exactly? They are a party in a lawsuit. They're party in many lawsuits, but the particular lawsuit in question was arguing that they were violating a patent in their source code. So someone was suing Apple saying, hey, you are violating our patent in your source code. And so what Apple needed is they needed someone to come and review their source code and to testify whether or not their code that they had was actually violating the patent. So they asked me to do that. So I had the opportunity to look at some of the source code for Apple's for some of Apple's software. Let's just say that. And what was interesting is I'm looking at some software that I've never seen before. And let's just say that the software for iOS is pretty complicated. It's a pretty elaborate project, with with lots of classes. And so the question is, how do you even go about getting your head around this software to try and be able to, authoritatively say that they aren't violating a patent? So the thing that I did is I went immediately and started looking for tests. And I found some because Apple is a pretty decent software company, and their engineers had written tests for the code under question. And so what I did is I looked and I saw the test, and in the test I could see, oh, this is how they expect people to run their code. Because you look at the test and you see them making objects, exercising the objects, and validating the results of the object. And I said, oh, wow, that gives me a great understanding of what their expectations are. And so from that basically script of a bunch of different uses of their code, I could then dig into the specific software and say, oh, I see now how it all fits together, how all those pieces fit together. So it's really, it's good for validating your software, but it's also good for describing how you, as an engineer, expect it to be used. Finally, I just want to end on this a little bit by talking about a particularly advanced topic. In JUnit testing, you can put in your class 4 additional methods, and you can see they have specific annotations, and those annotations are before class, after class, before, and after. And what those indicate is they indicate particular methods that are going to be called during particular moments in the life cycle of the test. So before class and after class, as you might expect, are going to get run at the very beginning of the test and at the very end of the test, and you can put any code you want to put in there. So sometimes you want to do some kind of setup or some kind of breakdown of code that is going to be relevant for all of the tests, like what might it be? Like maybe you wanted to establish a connection to a website, and all of your tests were going to use that connection to the website, and then when you're done, you want to shut down the connection to the website or to a database. And so before class and after class can contain code that's run at the beginning of all the tests in this class and at the end of all the tests in the class. And then before and after is code that is run before and after each individual test. So if there's some sort of common template code that you want to run before every single test and run after every single test, you can run that there. So again, establishing connections to databases is a real common one. And then when your test is over, breaking down the connection to the database. Maybe you have some kind of maybe you need to start up some kind of infrastructure and then you need to take it down before each test. And that's just common. You don't want to cut and paste that code for all your tests. And then in this case, that final one is a particular test that's just going to fail every time it's run. And I just had that last test in there so that I could have Eclipse give me that template code so that I could show it to you guys. Okay, so what I would like to do then is I would like to pause for a second and try it out. I would like to, we're going to go offline for maybe 10 minutes, so we'll come back at 11:05. What I'm going to do with the folks in the room is I'm going to share with you our bank account class that we had last time. I'm actually going to create a new project and share it with you. And what I'd like you to do is I'd like you to write a test that goes through and validates our add interest method, the one that we added yesterday. So for folks at home, you can take a moment and practice writing a test, practice using an assertion command, maybe that you haven't used before, and also take a look at the project properties so you can see where a JUnit test gets added. All right, so we'll be back at 11, actually now let's make it 11:07, and what we're doing is we're testing our JUnit, our ability to write JUnit tests. Okay, we're back, and we got a little ways through. We certainly, at least, we didn't all get through all testing everything. So what I want to do is just walk through some of the tests that did get written and see how we did, and just any commentary or recommended changes to the code as we look at that. So let's see, make sure our broadcasting looks okay. Looks good to me. All right, I'll shift over to the left side. All right, so on the left side we have the, let's bring up the code that's under test. So that's the code that's under test there. And you can see I've been using the code coverage tool, which is why I'm colored. And then let's see if we start on the right side this time. Boaz, can I pull yours up? No. No. Okay. Tim, pull yours up.
Okay, you can pull mine up.
All right. So we were working through it together, and we've got some good testing going on here. And if I run your test class, if I do coverage as a JUnit test, then we should see what gets run. And what do we get? All right, so all your tests are passing. I'm seeing that over here on the left. That's good. And seeing how much you're able to validate. And from this, I can see that you were able to get through the constructor and testing get balance. That's a good start. Now that most of the time, you were spending just setting up the testing framework, getting the imports and getting the assertions right, getting the code linking okay. I think that now that you had this test, it would be pretty fast to just go through and add a deposit, add a withdrawal, check the get balance, add a deposit, get a withdrawal. Let's see, the only thing on here that I would tweak is that the assert equals, just as a matter of practice, expects the expected value to be first. So by doing that, you'll get, it is an equivalent test, whether you put it at the beginning or second, because you're just asserting equality. But the error messages that JUnit gives back will at various points say, hey, you expected a 0. And if you put that second, it wouldn't reflect what you were actually expecting. So that would be the only thing that I would suggest. And that's a rather kind of a subtle issue. So that looks good. Made a constructor, you made sure it wasn't null, and then you asserted that your balance was equal as part of the initialization. Looks great. Let's see, Lisa, can I pull yours up? All right, you're 2, test 2. All right, and let's try and run yours. That's a problem with, that's some kind of Saros problem. Let's see if we can fix that up. Yeah, so I did organize imports because I feel like that was the problem. Maybe not. Let's give it a shot again. No test found in test J5. Everything looks okay to me here, so I'm wondering what exactly is happening. I will now work through it. Okay, so here's what I would do if I encountered that problem. The first thing I'm worried about is I want to just get it cleaned up so I can see it clearly. The red lines, for starters, are giving me a little bit of headache when I just try and edit the code. And so I'm going to, under source, do format. That's going to do some indentation for me. And then I'm going to save it, and I'm going to delete the import lines, and I'm going to then do organize imports to put them back in, just to make sure they were all clean. And in fact, it didn't come back okay. Let's see what's happening here. Save it, and let's try organizing imports again. Great, now it's asking me which do I want to import. The org.junit.jupyter test is the JUnit 5 versions. These org.junit.tests, I believe, are 3 and 4. So we'll stick with 5. That's good. Let's see what we can import here. That should have imported everything. I'm not quite sure why that didn't work. Let's see. All right, so it's compiling okay. Now do coverage as a JUnit test. There we go. Okay, so I'm not sure exactly what I fixed, but by re-importing the imports, I made sure that we were linking to JUnit 5 and sort of, shocked Eclipse into getting everything synchronized. All right, so as I just look real quick at code coverage, I can see that you tested the other constructor, not the one that Tim tested, but the one that takes a default balance. Great. You tested the deposit method, and you detested this method. you also tested the getBalance method. And you did that over here by first creating a bank account called Lisa, wishful thinking, and depositing $100, again, wishful thinking, giving you a total of $200. And again, like Tim, you also used the tolerance method of the tolerance value of epsilon because we're comparing doubles. So that's great. So between you two, if you were to put these two tests together, you would get coverage of both constructors and 3 methods. And so you can see that you could have multiple people working on the same code to generate some of these tests.
Oh, cool. So as long as one of the people's, well, the tests will always work if they work separately, like you can just combine them into tests.
Yeah. And so what would happen is you would have 2 tests that end up testing the same functionality, but that's okay. You know, because you're testing it, you're actually testing it with different deposit values usually. So that's actually a different test, although you wouldn't expect that different deposit amounts would give you different results, except maybe positive and negative would. Maybe you're not allowed to deposit negative amounts, but we didn't actually put a check in for that. So Boaz is up for it? All right.
It's not, yeah.
That's okay. We can walk through it.
I was having struggles at the beginning, and I finally got it to start working.
Okay, so let's see. It looks like it should be compiling cleanly. I'm not sure. I'm getting this error on.
Yeah, and I don't know why.
Well, let's see if we can figure it out. So for starters, I feel like boat is a typo for Boaz.
Boaz is always underlined in red, so I chose boat instead.
It's underlined in red because you run into some problem with Eclipse?
Just because my name's a typo, like automatically.
Really?
Yeah.
That's funny. That's not okay. I'm offended. Okay, so boat. We'll stick with boat. And I'm looking at this and I'm wondering, okay, you're defining, I see that you're making a class called, reference to a class called boat, and you're calling the constructor, and that looks okay. Then you're depositing money and you're withdrawing money. Oh, so you
Okay, keep going, sorry.
no, you're good. So the problem is you see that boat is underlined. That seems strange because we've got a valid variable. And so if I hover over this, it says boat cannot be resolved, there's not a field. Right, that's a classic Eclipse no information warning. So like there's nothing there that helps. It basically says, hey, boat's got a red underline under it. What I'm looking for here, though, is when something like that happens, I'm looking for syntax problems. Because what's happening is it's getting confused. Yep, there you go. It's getting confused about how to parse the screen. So yeah, so the problem was there was a period after the 25. You changed it to a comma so that the boat.getBalance was interpreted as a parameter rather than like floating point with 2 decimal points. Great, and so we have a warning up there about our imports. That's not important, but if we wanted that to go away, we could organize our imports and it would get cleaned up for us. Save the file and then run coverage, and we can see which ones he's testing. And we can see that he's testing our withdrawal method, which we didn't have in the other example, our deposit and filled out. So no one was able to cover all of them. But if I were to come over to Lisa's and grab her test, go back and drop it in Boaz's, and I were to go to Tim's, and I were to grab Tim's test, assuming that our epsilon is consistent in everyone's, and then I've got 2 methods called tests, so I need to just make sure that they've got different names, and I'm going to save that, and I've got an error with assert equals, and I'm assuming is an import issue. So sometimes when you cut and paste code, you get these complicated import errors, and the best thing to do is just to delete the imports and then reorganize them. Again, I want the JUnit 5 version of test. Boaz is continuing to edit as we speak.
Adding another one for you.
Thank you. So I'm not quite sure why our assert equals isn't, well, our assert equals hasn't been imported, and so that's a problem. But it's not giving me the opportunity to. So I'm going to just save it, close it, reopen it.
The import isn't the whole thing, maybe?
Well, we're not importing assert equals, which is a problem. And so here we go. Okay. So I just added the import for it, and now we're good. Okay, so now we're compiling those. Let me see if I can add the import for not null. Compiling that, great. Save all that. And now if we run your new test, or your new version of your test, with everyone's test in it, failed one, the one you're editing. Okay, so add interest. So what should have happened there? We deposited $50. We withdrew $25, leaving $25 in the account. If we were to add 2 as interest, that should be 200% interest. And so it should have been 100% interest would have been 50. So 200% interest would have been 75.
What?
Because the interest is the additional amount on top of the principal. So your principal is, if it was 100%, you would have a principal of 25. And then,
Okay.
so make a cert equals 75.
Right, because they're expecting 0.02 for 2%.
So if we save that and run it, okay, now we pass. Great. And if you look at our class,
200% interest.
we tested every single method except one where we deposited dollars and cents separately. And so, you know, what we just saw there is team coding. So everyone was responsible for writing some tests. We didn't specifically specify which things you were supposed to be testing, but if we had done that, we could have written a test for the entire class, you know, and maybe not 3 times as fast, but maybe 2 times as fast plus some overhead, even though we have 3 people. Reference the Mythical Man month. Okay, so great job. I think that was a good outcome for those. All right, so that was an example of testing out our JUnit test class and learning how to write them, and some of the work that's responsible for, and some of the work that we had to go through in order to make sure we linked in the JUnit library. Looking at how we could make sure that we had everything working. We ran into one example where we didn't have a test, one of our tests didn't pass, but it turned out it's because the bug was in our test, not in our code. So sometimes you see both of those in play. So let's see, what I would like to do now is I would like to introduce the idea of a JavaFX project and then use that as a framework for us to work through some of our if-else statements. So JavaFX is a technology that has recently been getting more attention from Oracle. And as the more recent versions of Java have come out, JavaFX has gotten refactored with an attempt to try and bring it to more to the mainstream. JavaFX is a library for making windows and widgets in the windows, putting text fields and buttons and things together, like kind of like making. I guess it's a little bit like making an app, but it's for a desktop or laptop computer, as opposed to making a website, but it has many of the same kinds of things that you would find in a website. It's just native code rather than running in a browser. So let's look at an example of making a JavaFX project, and we'll use that as our framework for doing our decision making. So let's see. So JavaFX, let's break over. And what we're going to do here is we're going to create a new project for us. I had one standing by, so that's like the cooking show issue. To do this, we're going to make a new Java project. And because there's a little, sorry, not a new Java project, after all that talk, a new project, and I want it to be I want a wizard. Show me my wizard. New project. There we go. So new project, and rather than selecting Java project, which is what we've done so far, I'm going to select JavaFX project. And the only difference here, it's still Java. The only difference is that all the connections for the libraries are going to be built into my project from the get-go. So I'll call it 07 decisions in JavaFX, just so that I know what I'm doing here. I'll go ahead and add the JUnit testing framework immediately at this point in the code, so that I can write high-quality code from the get-go. Hit Finish, and you can see that something's slightly different about the framework here. You can see that just like we have the JRE system library in our other project and JUnit framework that we have for testing, now we have this JavaFX library as well. And these are methods and classes that are useful for making the windowing environment, and it's cross-platform. So this is going to work on all the different platforms that we want to build on. And you can see there are some additional files as well. So in this example, as we open up our source file, you can see that a package has already been created for us called application, and a class called main has been created. This is you could call your class main if you wanted as well, but this is the way that the JavaFX project is set up. And there's actually a parallel file here which is written in a kind of cascading style sheet, which is a bit like what we have in websites, to add styling to your window if you're interested in doing that. For the time being, though, it's just empty. So in our main class, if we take a look at that, we can open it up, and we see that it's pretty simple, and you can see that there's a main function. And the main function, when it gets run, is going to call this method launch. Where's launch coming from? Well, launch is being inherited from this class called application, which is part of the JavaFX framework. When you do a a program that has user interface elements, it's typically implemented as event-driven programming. And what that means is you create a user interface, and then you let the framework that is helping you with the user interface run, and it's going to periodically call your methods in order to execute functions. So you will build your user interface, and then you will say, hey, if this button gets clicked, call this function, or this method. And the reason why you do that is because you don't want to sit there in a while loop forever. That's what the UI framework does, and it'll just tell you when some event has happened, and you can handle that particular event. So let's just start by seeing what happens when we run this with the default code out there. Let's run it as a Java application, and what we want to run is the main class, which is the one of a few in this project. And you can see in a very boring way, it pops up a window with nothing in it. And if you look over at the code that's associated with it, you can see that there's some elements happening here. Well, we're creating this thing called a border pane. So that's a container that is existing in this window that can hold elements. We have this thing called a scene, and we initialize the scene with that border pane, and we can see that it's 400 by 400. So the first thing that we can do is we could potentially change the size of that window by changing those numbers there.
Is there a way to make it automatically like read from the device what size the screen is?
To do like full screen?
Yeah.
There is. I don't know how to do it offhand.
Okay.
Yeah. And I've done it before, but I didn't do it in the JavaFX framework. I did it in the Swing framework.
Okay.
So we'd have to check on that.
So what does 300 mean then? Is that just pixels?
Pixels.
Okay.
Then we say, hey, apply some style to it, and you can see there's kind of a complicated framework for doing that. But if you notice, what it's doing is it's saying get the style from that file application.css. And then there's this setup code where it says show a particular scene, set the scene, and then show it. So the metaphor in JavaFX is a theater metaphor. It's as if this window is a stage, and on the stage you have a scene, and you put the scene in place, and then you show the code. All right, so let's change this, and let's instead of doing our border pane here, let's do a slightly different one. Let me take it from my code over here. And I'm going to comment it out for starters so we can step through it. So the first thing we've got is just a comment, and we're going to have a different kind of framework for placing elements, something called a grid pane. And what the grid pane is going to do is the grid pane is going to enable us to put things in particular locations by an XY location. It's not like a canvas. It's not like putting pixel locations down. It's more like a table, if you've ever used a spreadsheet, picking out particular cells in a table where we want to put things down. And then at the bottom, we're going to create a new scene in which we put that grid. Oops, I'm not going to delete that line. We give it styling, and then we show it. Make it 400 by 400. So right now, we create this grid pane. We say we want it centered in whatever scene we're going to put it in. That's what line 23 does. We're going to give it some padding and some gaps. This means that in every cell in which we put things, there's going to be some space around it. If we run that right now, we'll see... sure I'm running the right thing. Let me make sure I'm running the right code. And we don't see anything different. It's still a 400 by 400 window because this grid pane is a abstract idea of how to place things in the screen. And so we haven't actually placed anything. So that's the next thing we need to do. So let's create a text field. So a place where we can put some text. And let's put it at location 0, 0. And as long as we were going to have a text field, we might as well put some text in it. So let's go ahead and say input.setText equal to hello world, because that's how we go. And we're going to put it at position 0, 0 in our grid world. And the grids are going to lay out, are going to try and align themselves so that we get a clean layout. So text field is one of many things we can put in our window. Sorry. And so you can see that we've got a text field now, and this is actually a field in which we can type things.
No, what happens if you enter?
Nothing, because we haven't added an event to it yet. Hitting enter would be an event, and that would be something that we would need to connect to. We need to bind to that event.
So does the fact you can edit it come from the text field class?
Yes.
Oh, okay.
So it's an abstraction of a text field that you can edit.
Can you make is there a text object that you can't edit?
Sure. In fact, you can probably just turn off editing. I've not checked this, but I'm going to guess there's something like set enabled or is enabled. Is editable. Set editable. There you go. Set equal to false. So now I'm just guessing. I haven't actually researched this, but I'm guessing that.
That's a good guess.
Yeah. So now you can't edit it.
Oh, that's so cool. That's so neat.
If you want it, the text field is specifically for editing though. If you wanted text on your screen, there's other widgets that are like labels that you can use instead. Usually the reason why you turn off text field editing is because for a moment you're processing, you don't want the user to type something. Like maybe you're waiting for something from the internet to come back. So let's add another text field. And the idea here is that we're going to have one field for input. We'll have one field for output. And I'm just going against exactly what I just said in the sense that we are going to make it not editable. But we'll change this so we know which field is which. Now you can see we have an input field and an output field, and you can only edit the input field. You can select that, but you can't edit it. You could probably even do set selectable, I bet. No. I bet there is a way to do that. I just don't know what it is offhand. All right, so you can see we're adding it to position 0, 0 and position 0, 2. So there's a position in between, and we're going to put a button in there that says that's like a processing button. And so we'll add a button in the middle there. Solve maybe isn't the best word. We'll say processing button. And we'll just have the button say go on it. So now the way we do a button is we need to make the button itself, and then we're going to put it in a little container called a horizontal box. And we're going to add some alignment to that box by setting its horizontal alignment to being centered. And then we're going to attach the button to that box, and then we're going to attach the box to the grid. Position 0, 1. So a little bit of a hierarchy there. And now we've got an input, a button that says go, and an output. Again, just like the text, we can click it, but it doesn't do anything because we're not doing anything on that event. So let's add that event. The way we do it is there are different ways that you could do it, but what we're going to do is we're going to create an anonymous function. Or rather, that's not correct. We're going to create a class on the fly, and we're going to pass it in. So the way in which we attach to an event is we pass in a class that does the work that we want it to do. So we're going to attach an action to our button. The method that we're calling is setOnAction, and what we're going to pass in is a new class that we're writing on the fly. So you can see that we have a new event handler action event, but we're actually going to put the body of this class right here. That's never been written anywhere else. We're writing it for the first time. Rather than putting it in a separate file, because we're only going to use it here, we're just going to write it in this spot. And then this class, that whatever we pass in to setOnAction, has to implement the handle routine. And then the handle routine is going to get called with all the different events that can happen. If we want to do different things on different events, we could check to see which event we're being passed in. But because the only thing we really expect the button to be getting as an event is the click event, when that click event gets activated, when someone clicks on the button, then this code is going to get run. It doesn't get run as we're going through and building the event. It's sitting around waiting for us to click. And so when we do get something clicked, we're going to say, okay, well, what was the text in our input? And then we'll set the text of our output to clicked, and input was, and then we'll also change the color of our output when it gets clicked as well. So now if we run our code, we have input, we'll just say hello world, and it says clicked input was hello world, but we ran out of space, so we'd have to make it a little bit bigger if we wanted it to work. And if we change it, you see that it changes every time we click it. So there are a lot of widgets that are available, and you can build up multiple kinds of interfaces if the way you want with this, and then you can build events into it as well. So what I would like to do is I would just like to use this right here as a place where we test out our decisions. So we're going to write some if statements in here, and from those if statements we'll just be able to validate whether or not our code is working okay. So let's see, how should we proceed? Let's go ahead and talk about if statements, and then we'll just write some. And it shouldn't be a huge challenge for us because we've seen these before, and the if statements in Python and the if statements in Java are very, very similar. All right, so let's go back to our slides. So what that gave us is that gave us a project that we could work with in order to test out some of our code. Of course, we could have done this in a main function. I just felt like, given some of the interest and some of the, the reality is that most people aren't running command line applications. Developers are, sure. System administrators are, but most end users are going to run some kind of a windowed application. So the ability to actually write a windowed application is not terribly hard, but that's an introduction to it. Chapter 5 is mostly about decisions, though, and it's about the control flow that's associated with if-else statements, and it's just worthwhile walking through some of that. And so Java has an if statement, and just like Python, the if statement is used to change the control flow to either take one of two options, an if option or an else option if both of those are there. And so we can carry out different actions depending on the nature of the data to be processed. So we have a condition in our if statement, and if it's true, then we do one thing. If it's false, we do something else. The if-else statement is like a flow chart with two branches, and each branch is able to have multiple statements. So let me see if I can sketch out what this looks like logically, and pull this off. So you're going to have some flow chart where this diamond represents the question that you're asking, and if something is true, then you're going to go down this branch and you're going to execute some code. But if it's false, you're going to go down this branch and execute some different code over there. And then after those two bits of code have been run, the control flow is going to come back together and rejoin along the bottom. So that would be an if statement. If we were to go back and think, sorry, that's an if-else statement. And an if statement is slightly different because an if statement is going to just have a question that's asked. If the result is true, then we run some particular code. And if it's false, we just skip that code and don't do anything. And then we come back together to join below it. So notwithstanding my 2-year-old drawing here, we have to see how to execute this or how to create these control structures within Java code. So the if statement is a flowchart with one branch and one skip. And in a lot of ways, an if statement is like a fork in the road. And the reason why I say that is because you either take one fork or you take the other. If you have an if-else statement, you don't do both bits of code. You have to choose one side. And thinking through what those different situations are is important for writing well-formed if statements. So a couple parts of the component. So let's go ahead and write one, and then we'll walk through exactly what's happening in this. So if we go back to our code, let's say that what we're going to do here is we're going to evaluate a, someone's going to type in some text. It's going to be a grade point average, and what we're going to do is we're going to write out whether or not they passed or not. Okay? So what we'll do is we'll say, first thing, we know that our text that the person has typed in is in, and so we need to convert that into a double. And I'm going to try and do that on the fly here. Double grade equals new double in. All right, so that's a constructor creating a new double. One of the things about the double class is that you can pass it a string, and if it represents a valid double, then it will convert that into a number that we can work with. And the reason why we're converting it to a number is because our if statement, we want to compare it to a threshold. Now, if the string we pass in doesn't convert to a double, that's going to throw an exception, and our program is going to crash. But for now, just for the purposes of testing if statements, we'll assume that our user is compliant and doing helpful things.
So hang on, what's going on with the in brackets around the double?
So,
What does in mean?
so in right here is just a variable name that is holding the string that our user has typed in.
Sorry. I see it now.
Okay. So what we want to test is we want to test our if statement. So what we're going to do is say if grade is less than, what's a passing grade?
2.0.
Well, let's assume it's a percentage. 60? 60? Yeah, the people who answer, right, know exactly what the lower bound is. 60.0. Okay, so if your grade is greater than, or I guess it's equal, right? Greater than or equal to 60.0, then this is going to be the pass condition. And we're going to have an else condition, and that's going to be the fail condition. All right, so let's just look at this for a second. We have an if reserved word. It's color-coded in Eclipse for us in this purple to indicate it's reserved. We also have this else reserved word. In Java, when we put this condition in here, we actually have to put parentheses around the first level condition. If we leave it unspecified like that, it doesn't parse cleanly. This is different in different languages, but in almost all languages I've worked with, if you put parentheses there, it's not a problem. And so I tend to always put parentheses just for clarity. So the parentheses in Java are part of the syntax. Then within these parentheses, we have some kind of condition. And so whatever we have in there has to evaluate to either true or false. And so the greater than or equal characters are a relational operator that asks, is the thing on the left greater than or equal to the thing on the right? And that's either going to evaluate to true or false. And depending on what it is, we're going to run one of two branches. So this pass, the place where I put the pass comment, is one branch of our fork in the road, and fail is the other branch in our fork in the road. And based on the way I've written this, there's no way that both branches are going to be run in one pass through this code. It's either going to be the pass or it's going to be fail, and that's how the control flow operates. So let's say it is pass. Let's maybe, in this case, we'll say output.setText equal to you passed. And we will be as enthusiastic about saying you failed. You failed! And then we'll clean up the code at the other side, and we will not overwrite it with more text, but we'll set the styling. Okay, so if we run this, we're given the opportunity to type something in. Let's see how this goes. Type in a number, 10, and you failed. Too bad. 20, go, failed. 30, 40, failed. 59.9, failed. 60.0, you passed. So what's happening is each time we hit the go button, this code is being called as a handler. So that's being called by the JavaFX framework. So let's add something else to it. Let's change our coloring. That was kind of a it would be nice if the color supported what we were saying as well. So these are Rgb colors. Are you guys familiar with Rgb? So it's a way of specifying colors where you specify the amount of red, the amount of green, and the amount of blue. You specify it in a number between 0 and 255, and 255, 255, 255 is white. So when you mix RGB, you mix it like light, not like paint. Because paint, you get a lot of color in there, it gets black, but light, you put a lot of light together, it gets white. So we're going to say If you passed, we want it to be more green. So let's see, Rgb. So let's swap 193 and 255. Let's try that out. You can see what I did there now is I moved the color setting into the different branches. And so an important thing to recognize here is that you can have as many lines of code as you want in the true branch or in the false branch. And the amount of code that's there is just dictated by these curly braces. So these curly braces create a new scope. Remember we talked about scoping last time? And within here, just to reinforce the idea of scope, we could, for example, have said string message equals you passed. And then use that local variable as the input here. That's not necessary. But we could have done that. In this case, that's a local variable. The scope is the curly brackets around it. And so that message variable that we've created right here is not going to work here. Because message is only scoped within these curly brackets, and these curly brackets are not a child of these curly brackets. They're siblings if you think about it hierarchically. Does that make sense? How the scoping doesn't work? Now, if we created a new local variable over here, now we have two local variables in our code that have the same name, but they don't collide because they're in different scopes. They have the wrong message. So now we have 3 lines of code in each one of our branches. You're only going to run one or the other for each time this code is run. So we say our input is 0, our output is you failed, and now we have 60, and we get an output you passed. And the color reflects sort of green and reddish to sort of indicate the results, because sometimes you need a little color to support your decisions. Now, of course, you can put 100, and we didn't do any checking, so you could put 200 in there, and you could put -1 in there, and those are all weird grades, but we didn't do any checking, we didn't do any feedback for that. And then just to point out that if we typed in and hit go, our program crashes, and you can see that it throws. Actually, it looks like JavaFX is pretty robust, because while our program threw an exception, I think it's going to keep running. That's great. No, it did crash. Oh, great. It keeps running. So we're throwing an exception. What happens here is that this code throws an exception, but JavaFX is able to just catch general exceptions. We would be better off doing something like this. Defining the variable outside our try-catch. We haven't introduced exceptions yet, so this is all.
Well, you did this in Python.
We did it in Python, that's right. It's a common. And what I'll do here is I'll add another. Okay, so what does that code do? That code initializes a variable called grade. It then attempts to set it equal to a new double by converting our test input into a double. If that fails, if this doesn't convert to a double cleanly, we're going to call this exception here. And if that does happen, we'll set our grade equal to null. And so what we'll do now is we'll add another check here, and we'll say, well, if grade equals null, then we know something went wrong. And we will say, please enter a number. And we're enthusiastic, so we'll put an exclamation mark. And we'll make the background white. And then we'll add this now to a chained if-else statement. So in this case, let's see, why am I getting an error here?
Doesn't the else need brackets around the if?
I forgot my closed curly bracket. Okay, so now we have multiple cases in our if statement. And again, just like in a case where we have 2 options, this is an example where we're only going to end up running this block, or this block. We'll never run more than one, but we've split it up into 3 different blocks that we might run, and there are multiple checks happening. So the first check that happens here is to check to see whether grade equals null or not. And we're doing that first because if we end up looking at grade later, we don't want to compare a null to a number. That doesn't make sense. So if it does equal null, the only way that it could have ended up being null is if we threw this exception when we were trying to convert the string to a number. And so we have a message that reflects what happened. Please enter a number. And that's it. So fine. If we don't have a null, then we must have a number. And so then we check if it's greater than or equal to 60, we say you passed. So by the time we get here, we know that grade is not equal to null and that it's less than 60. And so in all other cases, we know that the situation is that you failed. So we could run that as well. So now if we just type in a bad grade, we run it, it says please enter a number. And you see there's none of that like exception throwing going on down in the console. 10, you failed. 60, you passed. Okay, well, what if they enter a number that's less than 0? What if they enter a number that's greater than 100? I mean, maybe there's extra credit. But let's assume you're not supposed to enter something greater than 100. Well, we better put some additional statements in here. After we check for null, let's check to see if it's greater than 100. If it's greater, not equal, greater than 100 strictly. And it says, we'll say, please enter a smaller, please enter a number less than 100. That's going to be too big for our field, so we'd have to make our field bigger. And then let's get rid of the pass, because we're not really passing there. And then let's see, if it's too high, then we'll go ahead and make it white as well. Make sure our color matches up. And if it's less than 0, we want to say, please enter a number greater than 0. And we'll make it white as well. So now we're checking several different bounds at once. Check first to make sure it's a number. Please enter a number. If it's a negative, say please enter a number gr. Need to make that a little bit bigger in order to see it.
Does 0 count as a positive number?
0 is neither positive nor negative.
Yeah.
10, 60, and 150. Please enter a number. Oh! So we'd have to make that field a little bit bigger in order to see it all. Good question is, how do you make that field a little bit bigger? I'm not sure, but it's going to happen up here when we create our text field. Yeah, I'm not sure. I would have to look up that, but I don't want to do that right now. There's a logical sequence to these if statements. If we had done something else, for example, if we had checked first to see whether it's greater than or equal to 60, we would have run into a problem in our logic. If we check whether it's greater than or equal to 60 before we check whether it's greater than 100, if someone types in 150, it's going to say you passed. And it's impossible to ever get to this code here. That make sense? It's not possible to get to that code because if we had typed in something greater than 100, we would have already executed this branch and then left our if statement entirely. See that? So it's important that we check for our most specific cases first, or at least cases that don't overlap first. How you do your brackets is kind of a matter of style. I prefer to put it a little compact, make it a little more compact. Okay. Close our running projects. Now, if you wanted to test this, if you wanted to test your if statement, you'd have to do something slightly different. You couldn't write this class in line here. You would have to make a separate object and then pass that object in, and so you could write a test class separately. Maybe we won't do that today. Okay, so the if statement. What did we see in that if statement? We saw a couple components. We saw the reserved words if and else. I don't know if you've noticed, but Java doesn't have something like elif that Python has. It just has a sequence of chained else space if. So you just use those two reserved words in sequence in order to get the chained else if statements. We had the condition. The condition had to be within parentheses. You have the standard portfolio of relational operators available to you. Less than equal, greater than. Double equals is a quality. We haven't looked at that. We'll look at that next lecture. You have a true branch and a false branch. One thing we didn't explicitly say is you don't have to have a else branch. So if you just have an if statement and no else branch, you have some code that may or may not get run if the condition is true. So you don't have to have an else branch. Just to note where the semicolons go and where the curly brackets go, if we look at our code and our if statement, there's no semicolon here. There's only semicolons internally for each of the individual lines that we're interested in executing. And the curly brackets cover the entire branch for whether it's an if statement or an else statement. And again, we've looked at this before. The indentation is convenient for us to understand how that nesting is happening, but the indentation itself isn't part of the language. So as ugly as this is legitimate because it's being controlled by the curly branches, not because it's being controlled by indentation. And if you want to fix that automatically, you can highlight it and do format element. That's a nice feature. So there's a natural indentation that Eclipse can recognize, but it's not required. Although I highly recommend it. Don't turn any code that you haven't run through a formatter, because it helps me to read it much faster. Okay, any questions about the if statement so far? We need to look at equality. We'll do that next class. Okay, so let's see. What I would like to do now is I'd like to do an exercise together, and what I would like you to do is I would like you to take the lines of code on the right, and I would like you to rearrange them so that the result of running this code is that weekday is incremented to the next working day. So weekday is a variable. It can take on the values 0 through 6, which represent days of the week. And after we write this code, we would like weekday to no longer be what it was, but to instead be the next working day. So Monday should go to Tuesday, and Friday should go to Monday. Not all the lines are useful, but all the lines you need are present. So what we'll do is we'll take 5 minutes, and what you can do is you can. Are we still sharing? We're still sharing the project that we did the tests in.
That we did with which tests?
I don't think I broke it out. Well, in any event, what we'll do is we'll take 5 minutes, come back at 12:05, try and work this out, try and work out these if statements, and then we'll look at what we came up with. So I'll leave the slide up on the screen momentarily. I'll just double check that. And we'll go away for 5 minutes and come back and look at what we came up with. So let me do that.
Should we make a new project, or are we getting?
I'll put the slide up in 1 second. I just need to double check. Okay, we're going to take a minute or two more. Finish working. Okay, we're coming back in, and class is finding this a little bit challenging, so I thought maybe we could work through it together. Let me see. If we look here, that's Tim's code. Boaz, why don't we take a look at your code and see what you've got. This is just a workspace for it. And unfortunately, because of the way the slides are set up, I don't have the code there, so let me see if I can just grab this for us. We can see it at the same time. This is some heavy-duty windowing foo. Nice. Okay. And shift this one over. And go nuts. Great. Okay, so the code on the right is what we have access to. And our goal is for us to increment our weekday. And so we said that 0 is Monday. And 5, 0, Monday, Tuesday, Wednesday, Thursday, Friday. So 5 is Friday. And then 6 is Saturday.
But you said it weird.
Right?
6 is Sunday.
It's, yeah.
Monday, Tuesday, Wednesday, Thursday, Friday.
Yeah, I know. You only had 6 days in
Oh, but I didn't start with 0. Classic error.
You did start with 0.
I did, but my fingers don't start with 0.
Okay, now I get it.
Okay, there we go. All right, so your first attempt was to check to see if weekday is less than 5, and if it is less than 5,
I switched those
but we don't have that available to us, right?
I did all this wrong.
So we have what are our actions that we have available to us? We've got a weekday can be set equal to 1, or weekday can be set equal to 5, or weekday can be set equal to 0. And just so I get this to compile, I'm just going to create an integer for weekday. So we're presumably going to get some kind of This happened. Say 0. Okay. So these are the actions that we have available to us. We also have the action of doing weekday plus plus, which will increment it. So what we're talking about is trying to find the next working day. So basically, what we want to do is we want to increment the number. We want Monday to go to Tuesday, Tuesday to go Wednesday, Wednesday to go to Thursday, so on and so forth. But when do we run into a problem? When doesn't that work? When it's Sunday, there's another time that it doesn't work. When it's Saturday, and when it's Friday. So basically, we need conditions for Friday, Saturday, and Sunday somehow.
I don't think Sunday would be a problem, right? Because it would just go on to the next day.
But the next day is 7.
Oh,
Right? So we have to make it go to 0.
Okay.
So actually, I did this wrong. Weekday can be 1 or 5. Okay, so what would 1 be? 1 would be Tuesday, so that's weird. 5 would be Saturday, so that's weird. 0 is Monday, so that seems really valuable because we're going to want to jump to Monday, and we're going to want to increment our weekday, our day if it's not Friday, Saturday, or Sunday. So if it's Friday, Saturday, Sunday, we want it to be equal to 0. But if it's anything else, we want to increment it. So what is our anything else? What's the normal case? When do we want to just increment it?
So 0 would go up, 0 through 4 would go up 1 would be weekday plus plus.
Does 4 count? Because we don't want 4 to go up by 1, because then it'll be Saturday. We want 4 to go to Monday too.
Yeah, so less than 5 should work, right?
So if we're less than 5,
Weekday is less than 5 than weekday plus plus.
so what if weekday is 4? It's Friday.
Oh, Friday is 4. Dang, right. Okay. So yeah, it should be weekday less than 4.
Everyone buy that? Okay, I think that's right. So if we said weekday is less than 4, then what do we want to do?
Weekday plus plus.
Weekday plus plus. Okay, so we've used 2 of our lines, and I guess if we count our curly brackets, 2 of our curly brackets. All right, so then we have an else, so we can say in all other cases, what do we want to do?
Weekday 0.
Okay, so let's do test cases in our head. Let's say that weekday is 0, so that's Monday. We're going to end up with 1, which is Tuesday. Good? All right, if it's 1, we're going to end up with 2. So it's Tuesday to Wednesday. If it's 2, Wednesday will be 3. That's Thursday. That's good. 3 is Thursday. It'll go to 4. That's Friday. That's okay. If it's 4, Friday, it's going to end up with 0, which is Monday. That's good. That's what we want. Saturday, Sunday, anything else is going to go to 0. So that's pretty good. Is there any case here that it doesn't handle cleanly? So the only assumption that's being made here is that when you start, weekday is a valid day of the week. So you're assuming that weekday does start with 0, 1, 2, 3, 4, 5, 6. If weekday was a negative number, like -1, it wouldn't work. Or if it was like -3, because -3 would end up becoming -2, and that wouldn't work. So an assumption here is that weekday is set to one of these valid days of the week before we start. Interestingly, if weekday was equal to 1,000, it would actually work, I guess, if you assume that the next day after 1,000 is Monday. But there is an assumption built in here that weekday is only one of these values when we start. All right, does that make sense? It's a little bit of a puzzler. It's a pretty good one. I think it stretches the thinking a little bit. Is the mechanism of the if-else statement okay?
Yeah. Does it have to be moved over to the right? The else?
You mean in terms of which line it's on?
I don't think it matters.
So,
Like, does it have to be there?
I think that's
no,
just
but like
syntax.
just move to the right. But
You mean
like,
indented?
yeah, indent.
No, that's okay because it's a sibling with if.
Okay. Then yeah, no, that's good.
But you could do it all in one line and it'd still be fine, but it's kind of hard to read. Okay, so that's a good answer. All right, so let's try another one. Try writing if statements. Oh no, let's not try another one because we're out of time. Yep. So, right. We are out of time, and so we cannot try another one. And so what we need to do then is we just need to summarize what it is we did today. Let's see. We'll do a couple of these to launch us next time, but in summary, what we did today is we looked in depth at JUnit test cases. We looked at all the different tests that are available to us. We looked at how to set up that framework. We looked at why you do it, and we did an exercise in it. We introduced the JavaFX framework and just gave you enough starting points so that you guys could understand how to go about building one of those. To do a more elaborate user interface, you would need to dig into some documentation on the different kinds of widgets you can have. But it's really helpful to know that you can make sort of a normal interface as opposed to the command line interface, which as much as I love them, I will say I am a fan of the command line interface. Most normal people do not have the patience to deal with command line, despite their power and elegance. And then we also looked at decisions, and in Java, in particular, we looked at the if statement, the if-else statement, and then we looked at how we could chain multiple ones together, how those correspond to different control flows in a flowchart. Yep. And so we will continue, if I recall our schedule correctly, we'll continue on decision making next class. Any last questions before we sign off? Administration or otherwise? Okay. On behalf of Santa Barbara and Westmont College, I want to thank you for tuning in and for your attention today. I will see you tomorrow.